This is how KGRA produces electricity from heat that's otherwise wasted into the environment. It's all based on something called the Organic Rankine Cycle System, or ORC. Let's start with the heat source. This is typically an engine, a furnace, or some other type of heat system that's got a smokestack or exhaust. KGRA attaches a fluid-filled coil, this is typically referred to as a heat exchanger, into the flow of hot gas to capture the heat energy that's escaping into the atmosphere. By doing this, KGRA's heat exchanger absorbs heat from the exhaust gas into the fluid inside the heat exchanger. A pump moves this now scalding hot liquid into KGRA's ORC power module. This device is very similar to a conventional steam power generation system, except that it uses an environmentally friendly refrigerant instead of water. This is good for a few reasons. Number one, it's safer than using water. Number two, it doesn't corrode like water. And three, because it vaporizes at about 60 degrees Fahrenheit, it means KGRA can make electricity from heat sources that were previously not considered to be good candidates for standard-based cogeneration. The hot fluid from the heat exchanger now enters the ORC device and vaporizes the refrigerant through another heat exchanger. With the refrigerant now hot and vaporized, it's got a lot of energy in it as measured by its temperature and its pressure. This high temperature, high pressure vapor now gets to work spinning an expansion turbine, which is connected to a generator. This produces electricity for the customer to use on site or to be shipped into the electrical grid. Now that the vapor has expanded through the turbine, its ability to perform mechanical work has been exhausted, but there's still heat trapped in that vapor. So we dump this heat into a device called a recuperator. This serves two important functions. Number one, it preheats the incoming refrigerant, making the system very efficient. And two, it reduces the burden on the cooling system. The cooling system is required to generate what's called the delta T, or simply the difference in temperature between the hot and cold sides of the system. The larger this temperature difference, the more efficient the system will be. With the refrigerant now sufficiently cooled, it condenses back into a liquid from its vapor form and is circulated back through the recuperator and into the vaporizer for the cycle to begin again. It's simple, really.